Okay, so today we're talking about basically how arcs and chords work together. So this says properties of chords, but really it has to do, all of this has to do with arcs as well. So we're still sort of talking about arcs. So a chord we've already defined, it's a segment with endpoints on a circle. So here we've got a chord, oh, new pen. Endpoints on the circle. Any chord divides the circle into two arcs, a major arc and a minor arc. Now, actually, it's not always a major and a minor arc. What type of chord would not divide it into a major and a minor arc?
Diameter.
Perfect, a diameter. When your chord's a diameter, it just divides the circle into two half circles, two semicircles. But otherwise, it's going to make one that's bigger than the other, so that would be a major arc and a minor arc. In the same circle or in congruent circles, two minor arcs are congruent. This is basically what we have here, just overview before I get into that. I jumped ahead of myself here. We've got 4 properties of chords to talk about. Okay, that's what we've got on this page. It's just 4 separate properties of chords. These 2 and 3 work together pretty closely. But right now we're just jumping into the first property. It says two minor arcs are congruent if and only if their corresponding chords are congruent. The phrase if and only if in math means it works both ways. Means if the corresponding chords are congruent, then the minor arcs are congruent. Or if the minor arcs are congruent, then the corresponding chords would be congruent. So arc AB is congruent to arc CD if and only if segment AB is congruent to segment CD. So in this particular one, they gave me these little markings that told me the segments were congruent, the chords. And so that means that this arc is also congruent to this arc. If we know the chords are congruent, then the arcs they cut off, basically, of the circle are also congruent. Now, I kind of want to jump to this 4th one because this to me goes better with number 4, because this is talking about how do I know that arcs are congruent and chords are congruent. So if the arcs are congruent, the chords are congruent. If the chords are congruent, the arcs are congruent. This property that I'm putting 4 down here, this is another way to know if chords are congruent. If 2 in the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. Okay, so in other words, I can say that AB is congruent to CD because we're talking about the chords. That would be segments. If and only if they are both the same distance away from the center. So the reason this is a right angle, remember, is that for me to talk about distance from a point to a straight object, I want the perpendicular segment. That's the shortest distance to that thing. So that's why there's a right angle there, just to say this segment does indicate the distance from E to segment CD. And this segment does indicate the distance from E to segment or chord AB. So basically, it's this being congruent to this that makes those chords congruent. So if EG is congruent to EF. So those are 2 different ways that we would know that 2 chords are congruent. The first one up there on number 1, that was if they have congruent arcs. And this one is if they're both the same distance away from the center of the circle. 2 different ways to tell if chords are congruent. Now, this second and third property here, they both have to do with what happens if you have a chord and you have a diameter. If you have a chord, then there's got to be a diameter at least somewhere that intersects it. But both of these are saying what happens when the chord and the diameter are perpendicular, meaning right angle. If one chord is a perpendicular bisector of another chord. So if not only it's perpendicular, but it also has these congruent pieces on either side. I don't know about then the first chord. Well, okay, yeah. So, okay, let me go back. When they say if one chord is a perpendicular bisector, the one that's the perpendicular bisector here is this one. Right? Because it's perpendicular to this chord and it bisects it. Then the first chord, meaning the one that is the perpendicular bisector, it has to be a diameter. So if QS is a perpendicular bisector of TR, and that's not very easy to see, but that's supposed to be a T, then QS is a diameter. Another way this is put sometimes is then QS must pass through the center. Same idea. But sometimes problems are stated sort of more that way. If it passes through the center. And then basically kind of sort of the flip side of this, if you have a diameter, meaning you already know it passes through the center and it's perpendicular, so it passes through the center and it touches your chord at a right angle, then it does bisect the chord as well. So if EG is the diameter, and also we know that EG is perpendicular to FD or DF, then this is bisecting that chord. So that means FH is congruent to HD. Now, as far as the and isn't really an example of the theorem as much as it is sort of a result that comes from that. If FH and HD are congruent, which is what this is saying, then these two arcs would also be congruent. Arc FG, arc F to G, would be congruent to arc D to G. It's really not an obvious second step. It actually takes a little bit of doing to get there. But it is always true. Okay, so what we've said here on this one, number 3, if I know that I have a diameter and it intersects another chord at a right angle, then I know for sure that these two parts are congruent. Now, the part I'm saying is not as obvious, but is always true, is that these two arcs would be congruent. The reason that's always true is because we can connect this to both of those and use either the Pythagorean theorem or congruent triangles to show that these would have to be the same. If these two are the same, these two will be the same. And if those two are the same, that takes us back to the very first property here. If you have congruent chords, chopping off the same size, chopping off two arcs, then those two arcs must be congruent as well. Okay? So questions on any of these? All right, let's go ahead and start using them. First up, we have find the length of the given chord. All right. Well, the first thing I see there is that I have two chords, AB and DC, and they're both associated with arcs. There's an arc AB and there's an arc CD, and those two arcs are the same. Well, if the two arcs are the same, then the chords are the same. So that means AB is congruent to CD. So since they told me the length of CD was 9, the length of AB is 9. We actually don't need that little segment symbol there because remember, if we're trying to say the length of a segment, we say the name without anything over the top. So the more accurate way to write that would be like this. All right, next, SQ. We're looking for the length of SQ. Well, we have a chord that is a diameter. It's perpendicular to this other chord that it intersects. So according to this one right here that says if it's a diameter and it's perpendicular, then it bisects the chord. So that means PR bisects QS. So if this side of QS is 11, this side over here of QS is also 11, and the whole segment altogether is 22. 11 plus 11. Okay. Next, numbers 3, 4, A, and B, we are talking about whether or not, how do I know if PR is a diameter of the circle? All right, well, the one that deals with knowing if it's a diameter is right here. It says if a chord is a perpendicular bisector. That's two things, perpendicular and bisect. Then it must be a diameter. It must go through the center. We know it's perpendicular, but we don't know that it bisects here. So we don't know the two things we're supposed to know. Let's say I have a chord. Let me just randomly think about what if I just know I have a chord QS. I can easily draw another segment to that that's perpendicular to that is not a diameter. I could do it here. I could do it here. I could draw lots of segments to that are not, they're perpendicular, but they're not diameters. So just knowing it's perpendicular is not enough to say that's a diameter. So I would probably just say not necessarily. Not necessarily. I need to know that, and I need a point here, I'm going to call it T. I need to know that QT is the same length as TS. If I knew that, then I could say, yeah, that's a diameter. Number 4A, this time I do know that it bisects. I know that PR bisects QS, but I don't know the other part I'm supposed to know. I'm supposed to know two different things, perpendicular, bisector. So here I know it's a bisector, but I don't know it's perpendicular. Without a right angle symbol right here, this could look like this. Just going through the middle is not enough to say that's a diameter. It has to also it also has to be perpendicular. So without a right angle symbol there, I'm going to say not necessarily. We need to know that does PR, is it perpendicular to QS? I'm trying to sort of shorthand explain myself. We don't know that. We would need to know that. For B, if SQ is 16 and the diameter of the circle is 20. So I guess we're assuming, no way. Yeah, okay, sorry. My computer popped up with a message that I thought was telling me that it was done recording. It's not. Cool. Okay. If SQ is 16 and the diameter of the circle is 20. So I guess we're saying is like this. How far from the center of the circle is SQ? Let's see what they're talking about. SQ is 16. And the diameter is 20. Okay, so if I have a chord that has a length of 16, and I'm not going to, well, I could write it like this for a second. And the diameter, I know that a diameter is going to be, let's put it this way. I know that I can draw a diameter that would be perpendicular to that. Okay, so if I draw a diameter that's perpendicular to that, then each of these two sides would be 8. All right. They said the diameter was 20. That means the radius is 10. So here's what I can do with that. I can make a right triangle by connecting these 2 points, or I could have done these two. Make a little right triangle down here. They're asking me how far this is from the center. So they're asking me this right here. What's the length of this dotted segment? 10. Yeah, every radius is the same. Good. Okay, I'm glad you guys caught that. It's easy to forget. So I have a right triangle that has a hypotenuse of 10 and a leg of 8, and I'm trying to find this side. So Pythagorean theorem. So let's call it x for a second. So x squared plus 8 squared equals 10 squared. Does anybody know off the top of their head this is a Pythagorean triple? What do you think? It is 6. Good. 6, 8, 10 is a Pythagorean triple. Very good. I'm impressed that you guys remember that so well. So when I take the square root, I get 6. So that's my answer. So 6 units of whatever type of unit it is. Okay. I sure hope this is still recording because it's asking me to sign into Google, and I have no idea why it would be doing that when we're in Google Classroom. It's a little scary. Okay. Next up, find the missing arc measures. Okay, arc measures. What we know about arc measures, this is the only one of these 4 properties that talks about arc measures. Well, that's not true. This one does too down here. But the main one is this one right here. It says if the chords are the same, then the arcs are the same. Okay, so are the chords the same? Yes. We have congruence markings on SR and TU. So SR and TU have the same measure. That means their arcs, arc SR and STU, arc TU. It can be kind of confusing here because we're talking about chord SR and also arc SR. So you got to be real careful to understand what you're being asked for and what you're talking about. If this angle, which is a central angle, angle SQR, is 85, then the arc is 85. Because remember, central angles have the same measure as the arc. So that's my answer. Okay, for number 6, we have to remember that we know the entire circle is 365 degrees. Where did I come up with that? That's hilarious. I was just having a moment there and thinking, did I say that yesterday? No, it's not 365 degrees. 365 is the number of days in a year. 360 is degrees in a circle, right? It's 360 degrees. So what I know from knowing these two are congruent, I know that these two arcs, AB and AC, are congruent. So if I subtract 360 minus 100, I know that those two arcs have to add up to 260. So what would each one of them be? Good, half of that, 130. If these two together have to be 260, then 260 divided by 2 gives me 130 degrees. Okay, number 7. Goes with this one right here. That if we know we have a diameter and we know it's perpendicular. So basically that means I see this dot and I see the right angle symbol. So those are the 2 things I'm looking for to know that. If I got the dot in the middle and the perpendicular right angle, then I know that not only are these 2 pieces of the chord the same, but also remember those 2 pieces of arcs are the same. So that's what we're using here. I've got the diameter because there's the dot. I've got the right angle. So not only would HL and KL be the same, but the arc HJ would be the same as the arc JK. I'm going to go ahead and say that. HJ would be congruent to JK. So if HJ is 55 degrees, so is JK. And they asked me for the measure of HK, which is the whole thing put together. So what would that be? Good, 110 degrees. Pause a second, let you guys catch up. And let me know if you're having any questions come up. You good? Okay, next up on number 8, we have to figure out what it's telling me. These little marks right here, this one here and this one here, they're telling me that the distance from E to the chord, that little distance and this little distance are the same. Remember that chords that are the same distance from the center are congruent. That's that fourth property. If two chords are congruent, if and only if they are equidistant from the center. So AB is congruent to DC, which means that 3x minus 11 has to be the same as x plus 9. And I can write that as an equation. And then I can solve it. And I get that x is equal to 10. Sorry. Okay, I'm working hard and rolling up my sleeves. All right, next one. I need to, all of these, you basically need to start out asking yourself, what are they telling me? What information have they given me? The information they've given me on number 9 is this, this, and this. All 3 of those arcs are congruent. Well, that's the whole circle divided up into those 3 arcs. There's no arcs that aren't mentioned there. So they're saying the whole circle is equal to 3 congruent arcs put together. So I can figure out how big each arc is that way, because the whole circle is 360 degrees. 360 divided by 3 is what? That'd be 4. 360 divided by 4 is 90. What's 360 divided by 3? Easy way to do it is 36 divided by 3. Yeah, 36 divided by 3 is the same as 360 divided by 3 with an extra 0. It's 12 or 120 in this case. 120 degrees. So each of these arcs is 120 degrees. What I'm going to do is I'm going to use that to help me find x, because over here x is squared, so that would be a harder equation to solve. Okay, so I'm going to use just this part. I don't need to use that part over there. 3x plus 11 equals 120. So that's 3x equals 109. I don't think it's going to be exact, is it? Or it's not going to be nice and pretty. Nope. Okay, so that goes 336 1/3. Does that seem right? 36 1/3. If you did it on your calculator and got a decimal, remember 0.3 repeating is the same as 1/3. You could have put 36.3 repeating. That's okay. Really, you could even leave it like this. 109 over 3 is fine too. All right. We're getting, what's the word? I'm having trouble with words lately. I couldn't find one yesterday. Progressively is the word. We're getting progressively more complicated, more complex on these. So I'm going to draw the next one again. Okay, they tell me that this part is 5x degrees, and this part is 80 minus x degrees. And I've got this. Okay. So I have the 2 things I need, the right angle and the knowing it's a diameter, to be able to say that There's no letter here. But to be able to say that this segment and this segment are the same. Knowing that this is a diameter and it's a right angle, that's that third property here, tells me that. Diameter and perpendicular. Now, that also tells me this arc and this arc are the same. So this arc up here must also be 80 minus x. Now, I actually see a way to finish the problem from here, but I'm going to go on and do it the way I was first thinking, which is, this is a diameter, right? So if this part is half the circle, this part's half the circle. So these have to match too, because this whole thing has to add up to 180 and this whole thing has to add up to 180. So if that's 5x, this is 5x. So what I could do now is I could write an equation that says add up all of these and you get 360. Alternately, I could have stopped here as soon as I knew this was 80 minus x and said these two have to add up to what? To 180. Might be the easier way to do it. Okay, so 80 minus x plus 5x has to add up to 180 because that's half the circle. So that's 80 plus 4x. And x is 25. Okay, so x is 25. Okay, this last one we're definitely going to have to draw because they didn't draw it for us. So suppose the radius of a circle is 17 inches and a chord is 30 inches, okay? Find the distance from the center of the circle to the chord. So I drew it like they're just random, like we don't know where each one is. The radius is in one place, the chord is in some other place. Because that's what they told me. Okay. Well, if we know, here's the center, we know that we can draw a line that goes through that chord someplace so that it's perpendicular. So that's what we're doing. We're going to say, okay, I'm going to draw it so that it's perpendicular here. If it goes through the center and it's perpendicular, now that means these two pieces are equal. They're both 15. I also know that every radius is the same as that radius over there. So this is 17. And I've made myself a right triangle. So when they want to know the distance from the center to the chord, that's this distance right here. And I've got a right triangle. And I can use Pythagorean theorem to find out. So let's call it x. And say x squared plus 15 squared equals 17 squared. And solve that. Oh, how nice. It's going to come out nice and clean. There's my answer. It is 8 units. Whatever the units are, it's 8 units from the center. Questions on that? Okay. So that is the notes, and the homework is more practice. That's basically just like these problems. And you are just like yesterday. You are, if you are in second or seventh period, because I may use this recording more than once. So if you are in second and seventh, you are doing the odds. And if you are in third or fifth, you are doing all of them. All right. Any questions before I wrap this up? All right. Thanks for being here. Bye, folks at home.